Find the third derivative, g triple prime of x, for the function g of x equals tangent 2x. So g of x here is the tangent of an expression 2x. Our first derivative will be the derivative of tangent, secant squared, leave the inside alone, and then multiply by the derivative of the inside to complete the chain rule. Now that 2 is not inside that secant, that 2 moves to the front. And then secant squared I will rewrite as secant of 2x first and then squared, just so we can take our second derivative here. So our second derivative, g double prime of x, will start with a power rule, bring the 2 down, multiply with the 2 that's already out there. So that'll be a 4. Leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside of the power, which is the derivative of secant, and that will be secant tangent, leaving the inside alone on each of those. So each of those will have a 2x, and then multiply by the derivative of that inside. Derivative of 2x is a 2 to complete that chain rule. That's a double chain rule. I'll bring that 2 out to the front with the 4, which will give us an 8. And then I have a secant times a secant. I will write that as secant squared, but I will keep it in the form of secant of 2x quantity squared so that we can take our next derivative. We're going to the third derivative here. I also have a tangent of 2x to the first power. So our third derivative will be a product rule. We will have the derivative of the first, and that's a power rule to start things off, so we'll bring the 2 down. That multiplies with the 8 to give us a 16. Leave the inside alone, subtract 1 from the power, it'll be to the power of 1. Multiply by the derivative of the inside, the derivative of secant is secant tangent, leaving their insides alone, but then multiply by the derivative of the inside to complete the chain rule. All of that is the derivative of the first times the second left alone, plus the first left alone times the derivative of the second. The derivative of tangent is secant squared, leave its inside alone, and then multiply by the derivative of the inside to complete the chain rule. So g triple prime of x is our first term. Let's collect any constants. We have a 16 and we have a 2. That will be a 32. We have a secant and another secant. That will be a secant squared of 2x. And we have a tangent and another tangent. That will be tangent squared of 2x. And then we have plus, and on our second term we have an 8 and a 2, the constants, 16. And we have a secant squared and another secant squared, secant to the 4th of 2x. So there's a common factor of 16. Let's factor that out to begin. And that'll leave us with a 2, secant squared 2x, and tangent squared 2x, plus a 1, secant to the 4th of 2x. And we also have a power of secant that can factor out. So in each of the terms, we have secants. Here it's a power of 2, here it's a power of 4. We can factor out the lower of the 2, that's the power of 2. So 16 secant squared of 2x. And factoring out a secant squared, that will remove both of them from the first term. So we'll have the 2 and we will have the tangent squared of 2x left over. And from the second term we will take out 2 powers of the 4, leaving 2. We'll have secant squared of 2x. So there's the factored, simplified version of the third derivative, g triple prime of x.